All right, so we're going to be talking about 5.2b, which is rounding decimals and comparing and ordering decimals. So when we compare and order decimals, it's just like comparing whole numbers. The only difference is that there is a decimal in the problem. Okay, so I'm going to give us two decimals, and then we're going to line them up on top of each other to determine who is bigger. So we have 0 and 93 thousandths. I know this is in the thousandths place because this is the tenths, hundredths, thousandths. Okay. Now I'm going to do another number, 0 and 194 thousandths. Just like any other number, we're going to compare each digit and its value. This means I have no wholes or no dollars. This means I have one dime here and no dimes here. Well, since I already know that I have one dime and one is more than 0, I automatically know that this number is bigger than the first number. So I know if I wrote it in a comparison sentence and a comparison expression, it would look like this. This is the bigger number, so it gets 2, and this gets 1. And this would read as 0 and 93 thousandths is less than 0 and 194 thousandths. Now I'm going to take one that might not have the same amount of digits in both numbers. So if I have these numbers here, all three of those numbers have different value. This number means I have $0, 3 dimes, 4 pennies. I would say this as 34 hundredths. This number means I have no dollars, 3 tenths, 0 hundredths, 4 thousandths. I would read this number as 304 thousandths. This number does not have a decimal. So this means this is 34 wholes. 34 wholes. There is a hidden decimal right here, which means I would have 0 dimes, 0 pennies. That's where that decimal comes into play. So if I was to write this with comparison symbols, I would write it based on how much the value of each place is. So now I'm just going to look at these two numbers. I have $0. That helps me out a great deal because now I need to move on. Both of these numbers have 3 tenths. So I cannot decide based on those digits which one is larger. Then I have 4 hundredths and 0 hundredths. Now 4 is bigger than 0. It doesn't matter that this is a 3-digit number or 3 digits behind the decimal, and this is only 2 digits behind the decimal. If I placed a ghost 0 right here, then it would be 3 digits behind the decimal. So I have 340 thousandths and 304 thousandths. Since this number has 4 tenths and this has 0 tenths, that would make this number bigger. Now this is in a sequence of 3 numbers. So unless it's asking me to put them in order from least to greatest, I'm going to be using my comparison symbols. Now I've taken care of this set. Now I need to take care of this set. This says I have 0 wholes. This says I have 34 wholes. Well, I don't know about you, but I would rather have $34 than $0. So 304 thousandths is less than 34. Now, if I was going to write those in order from least to greatest, the smallest number is this one. Even though it does not look like it, that does not look like the smallest number written out because it's 3 digits, and my brain tells me that's 304. But what this means is $0, 3 dimes, 0 pennies. $0, 3 dimes, 4 pennies. This is $34. So my next one in order would be 0 and 34 hundredths. And the largest one would be 34. And that would be in the order from least to greatest. Make sure when you are comparing decimals that you look at all digits. If you would like to use ghost zeros to level the playing field so that they all have the same amount of digits, that would be fine. Remember that if it's a whole number, if you do not see a decimal, it's a whole number, and that decimal is hidden right behind the whole number.